Alrighty. Hope things are going well. I'm gonna show you a little bit about factoring trinomials because I know that sometimes factoring is a bit of a problem, especially when you get up to more advanced mathematics and when you have to do a lot more factoring. And you need to understand how to factor because that is really the cornerstone of algebra in pre-cal and calculus because it really does tell you a lot about the solutions. So let's go ahead and do factoring of trinomials. Remember, trinomial or tri means three. So three. So you have one, two, three terms. One, two, three terms. One, two, three terms. Uh, that's what trinomial means. It means you have a term here, term there, so you have three. So we want to look at the first term. And the first term in this one is always going to be 1. So that is what we want to factor. We want to factor trinomials with the leading exponent to be 1. Now, we got to do a little work with number 3, but that's perfectly fine. Now, I want you to go back to the quadratic equation. So the quadratic equation says if I have ax squared plus bx plus c, this is what I have here. So this is ax squared, bx, and then c. This is what we call a quadratic form, quadratic equation. And if I put an equal sign and make it equal to 0, that's a quadratic equation. So that's kind of what this is saying here. So that is that. So what I want to do is factor this. And I don't know if you remember this or not, but if I solved this, if I took some factors of this, I would have x here and x here of this quadratic formula. And then I would have something like something here. And since both of these are positive, obviously these are going to be both positive. So I hope that you get to see something like this happening over here. So let's go ahead and do that. So here we go. So we're going to factor this trinomial with 1 right here. By the way, there is a 1 there. We just don't write it in math because it's really known. And so it's just 1. And it's redundant. We do in math. So here we go. So we have to factor. So factoring means, so when we factoring really means the reverse. Reverse of like FOIL, or maybe you know the box method. The box method is a way to kind of take two binomials and maybe do something like this. I'm just making up one. And we're going to this. So we're taking this, doing FOIL or box, and then going to this. Okay, that's kind of what we're doing, back and forth. So factoring reverses this. So we're going to take this and we're going to put it like this. This is what we call factor. So now we're going to go do that. So one way to learn this is that there's a couple ways of learning this. This is an easy one. So a lot of students, they might go into a college class and they might, your college professor might do something like 2 parentheses. And then they see the B and then they put like a B there. And the reason is because if you do the FOIL, B times B is B squared. Okay, the next thing is maybe this last term here. Now, some people might say, okay, you're going to take this 7, and over here, you're going to go 1 times 7. So you're going to take 7 times 1, which is 7, right? So that's 7 times 1. Now, you're going to think about how many terms or how many ways that I can get 7. So you're probably thinking, okay, 1 times 7, that's it. I can't do anything else. That's it. That's the only combination. So you're going to go over here. You're going to put 1 to 7. Now, the only thing you have to really do is focus on the signs. Now, when you focus on the signs, since you have 2 positives, you really can't go wrong. So if I have 2 positives, I know, I know, I know that this has to be two positives. I know. There's no way. 100%, 100%. That's two positives because that's how it's going to go. So now this is called the factors, and you can check this, by the way. So if you want to do a little quick check, you can go this times this, which is 1b, this times this, which is 7b. And if you add those up, you should get 8b, which is that one right there. That's one way you could check pretty fast. You could foil. You could foil it back, and if you foil this, you should get this. So that's one way of doing this. There's another way that I want to show you that's going to be important as we move on. But that factor is done. So let's try this one. Okay, let's try this one. Now, looking at this, remember, this is just a 1. We just don't, it's redundant in math. So you can kind of look up here, it says A is 1. Well, that's A is 1 in this term here. Okay, so now we're going to look at this and how to factor this. So I'm going to show you another way. And this way is that, some teachers, this is called like the diamond method. So they call it the diamond method. And the diamond method, it kind of looks like a diamond if you kind of draw one in there, or big X, doesn't matter. But here's what you would do if you're factoring in this case. Well, you would say that, take from this. I'm going to kind of do some underlined work here. So I'm going to take this guy and I'm going to take this guy and I'm going to go A times C. Then I'm going to take B, which is this guy right here, and put right there. And then we're going to add or subtract, by the way. Now, that's kind of how you would set up. And this would be your two factors, whatever you get. So let's try this. So let's draw your diamond. I'm going to take our thing here, and I'm going to go try to do this in order for you. I'm going to go this times this, which is 10. Now, is it positive 10 or negative 10? Well, obviously, positive and positive make a positive. So you can't go wrong there. The bottom piece says, I'm going to take this guy here and put that right there. Okay, so that's kind of like your B. You're really thinking about this here into this one. So you put that there. Now you kind of run through, these two factors here. So I'm going to take this 11, this negative 11, or my apologies. I'm going to take 10. I'm going to take that 10, and that's going to be 1 times 10 times 1 is 10. Okay, so that's 10. Now I'm going to think of some numbers that make 10, some factors. So maybe 1 times 10, 2 times 5. That's it. That's all I can do to break down 10. Now, what I'm doing is that I need to think about what two of these make multiplies of this and make 11. What two make 10 and subtract or add to negative 11. And if you said this one, you are correct. So I'm going to put 1 and 10. This one we don't need. Now, 1 times 10 is 10, but 1 and 10 don't make negative 11. So guess what we're going to have to do? We're going to put negative and negative, because negative times a negative, remember, a negative times a negative is a positive, and that makes positive 10. And negative 1 minus negative 10 is negative 11, and that makes 11. So this and this is your factors, but we don't want to leave them this way. We want to put those where n minus 1 and n minus 10. Do you see where those come from? You want to make sure that the signs come with it, with the n in charge. And this could be an x, doesn't matter. In this case it was a b. So that's kind of how you would factor something like that. Now, and that's all you have to do. If you were to solve this, we would add something different, but we're only going to factor right now. We're only going to factor with a being 1. So let's look at this one. Now you're thinking that, okay, that's a 2, and we need it to be a 1. And we got to do something. Well, first off, we always want to make sure that this is in order. Now, when I say it's in order, let me kind of make a little box here so I can kind of do that. When I say this is in order, it wants to be like this. So ax squared plus bx plus c. Do you see how this is a 2 and this is a 1 right there? Yeah, you can kind of think about this, but what is anything to the 0 power? Well, anything to the 0 power is 1. And that's why that's c, because if you think about it, x to the 0 times c. X to the 0 is 1, and that's just going to be c. So you have that built in already. We just want to make sure that this is, going down exponents. That's always something you want to check for. Okay, next thing is I have a 2 instead of a 1. Is there a possibility that I can take a 2 out? Well, do you remember what the GCF is? Greatest common factor is? What if the greatest common factor is 2? Do you see why I take a 2 out? Because that would be x squared. That would be 11x, and that would be what 2 from that is going to be 30. Do you see what I did? Now, what do you do with this GCF? Well, my terms is that you take this GCF and you just flush it down the toilet for now. You don't need it. It's not going to do anything for this situation. Later on, it will, but it does something for your graph. If you were to graph this, it would do something. But we're not graphing this. We're trying to factor this. We're trying to factor this. So this is the same process. These are both positive, so there's no way that we can get this wrong. So you make your two things. This is x. This is x. This has to be positive, because that's guaranteed, just like we set up here. So now you're thinking, okay, what do I need to do now? Well, let's take 30 times 1. So remember, that's a 1. 30 times 1 is 30. Now let's try to break down 30. So 30 is 1 times 30, 2 times 15. Let's see, what about 3 times 30? I'm sorry, that's 3 times 10, so that's a 10. Are we close? No, we still need to move on a little bit. We got to get 11, so let's take some more here. 4 does not go into 30, so 4 doesn't work. So what about 5? 5 and 6. Okay, 5 and 6 do make 30, and if you add those two together, they do make 11. So I bet you anything, those are the two, and you would put those 5 and 6, and believe it or not, that foiled together should equal that. So here's our factors. So I'm hoping that you're kind of seeing how to factor trinomials with a equals 1. Now there is another way of looking at this without a being 1. And I want to show you that too, because when we do this way, this simple way, we are actually forgetting something. We're actually skipping something. That's very important when a is greater than 1. And that's for another later video. So I just want to show you when a is equal to 1, because this is kind of what we do. But I do want to show you on this next one what happens when I don't want to you skip a step. So this is the step that I want to show you, this extra step. So I want to show you an extra step. So I'm going to kind of do this, walking you through it a little bit, but I want to kind of do it kind of fast because of the time and stuff like that. So I'm kind of looking at this. I want to make sure that this is ax squared plus bx plus c. So that's the same kind of form. So the form's good. So that's a check. So now I want to look for a GCF, greatest common factor, because There's a 5, 30, and 40, and I do believe that the GCF looks like it's going to be 5, because that would be 1. So if I take a 5 out of all those terms, now if you don't know what I'm doing here, I'm going to do it for you. So I'm going to take a 5 and I'm going to put a big parenthesis, because that 5 is kind of, I'm taking a 5 and I'm removing it. If I remove a 5, I get x squared. If I remove a 5 from 30, I hope that you're getting the math right. Isn't that 5 times 6, which is 30? Yeah, negative 30. I don't worry about the negative. Okay, how many 5s going to 40? That's 8, right? So I'm going to take 8 out. Now, so what I did is I took a 5 from every single term. Now, you could check your work by distributing. You could do that. You should get back up to there. But that's not what we're going to do for here. So I'm going to go ahead and just cross that 5 out for now. So what I'm going to do now is that I'm going to kind of just take this downstairs, and I'm going to leave that 5 out, because I don't want to deal with it. It's pretty much gone for now, unless we use it later on, which we can, but not important right now. So I have this. Now, I'm going to show you this other way. So let's say you're doing this and you make your little diamond here, and remember what goes up here, right? 1 times 8 is 8. This negative 6 goes down there. Do you see how that works? So we're multiplying and pretty much adding here. So what 2 items are going to be here? So you're going to look at 8, or 1 times 8, which is 8. So you can look at 8. That's 1 times 8, 2 times 4. Now I think that's all we can do. So it's going to be 2 times 8. So I'm going to write over here, I'm going to go 2 times 4. Now I'm going to show you this other step. Remember, I'm showing this extra step because this is technically what we would skip. This is technically what we would skip on a certain situation like this one. But I'm not going to skip this time. I'm going to take this and I'm going to do something with it. I'm going to take this guy here and I'm going to go x squared. I'm going to rewrite it. And you're probably thinking, why? You're going to find out here in a minute. Believe me. So I'm going to take that first one right there. I'm going to go to here. I'm going to go to here and I'm going to say, okay, this is positive 2. So I'm going to go positive 2x. Now you're probably thinking, why did I add an x? Just go with me. Just go with it. Then I'm going to take this 4. And I'm going to go put that 4x right there. Just go with it. Then I'm going to take this 8 and I'm going to add it right there. Now, do you see what I did? What is 2x plus 4x? What is 2x plus 4x? Oh, we forgot something. We got to make negative 6. Oh, we got to be careful. Before we jump into this step, I'm sorry, we should make a negative 6. So that means that one of these has to be a negative, or both. Guess what? That's a negative and that's a negative, because negative times a negative is a positive, and that make negative 6. I apologize. So that means we're going to take these 2 signs and we're going to put a negative. Okay, you might have to rewatch that part a little bit, but that's fine. So, do you see how negative 2 and negative 4 gives you negative 6? Do you see it? Do you see this negative 6 right here? Do you see how this is negative 6 right here? If I add those together, by the way, that's not a yeah. These 2 should be that. Now, here's what we're gonna do. You see how there's 1, 2, 3, 4. Do you see how there's 4 terms? What we're going to do is we're going to split in half. So we're going to split them in half because there's 4 pieces, and we're going to split this in half. So get another pin here. I'm going to split this in half. So I have 2 and 2. Now I'm going to look for GCFs. So so I'm going to cover this side. And I'm going to do the GCF of this side. So the GCF of this side is going to be, what can I take out of these 2 terms? GCF of these 2 terms. Did you say x? Did you say x? I hope you did. Because if I can take an x out here, I can take at least 2, or sorry, 1, and then 1 from here. So the GCF has to be x. So now what is the leftovers? Well, the leftovers is x minus 2. Okay, you see that? Now, if you don't believe me, distribute. What about over here? Well, let's see, I have a 4 and an 8. I can take out a 4. Now put a big parentheses. And then what do you have left over? Well, I have negative x plus 8. Okay, oop, not plus 8. That should be 2. So you're probably thinking, okay, great. What are you doing here? Do you see how these are so close to being identical? Because we got to do something. What if we take something else out? So what if I take a negative 4 out this time? Wouldn't this become x minus 2? If I take a negative out of both these terms outside, if I take a negative out, don't I get this left over? And do you see how these are the same? That is one of your factors. That's one of your factors. This one and this one become that one. You see how those are the same? So you're probably thinking, okay, now what? Do you remember the GCFs that you took out? Remember these GCFs? This x and minus this minus 4? X minus 4. Now, there you go. Now you're probably thinking, great, I did that, but what was the point? What was the point of this? So I'm going to go ahead and cover this up because I'm going to show you what I did. So I'm going to go back. I'm going to go back all the way up to the original here because I'm going to show you what I did. So you're probably a person that says, okay, I'm going to just go ahead and do that, right? I'm going to go x and x, and then I need to make 8, right? So I need to make 8. So you're probably thinking 1 times 8, 2 times 4. I know it has to be that, so you're going to put 2 times 4. Now you're thinking about the signs, right? So let's say negative and negative. And the reason it's negative, negative, because if you do this to it and do this to it, don't you get negative 6? Well, guess what? You see what you just did here? Ta-da! Those are the same. And you're probably thinking, why did you just go through all this stuff if you can just do that? Well, let me make sure that you understand this. The reason we didn't do all this, the reason we just did this, because A was 1. That's the reason. We skipped this. We skipped that step. We skipped this step because A was 1. Now, on the next video, or a video that I'm going to do here, A is going to be greater than 1, or maybe A is not 1. That's where we have to do this extra step because we have kind of like a bonus feature into it. Yeah, and it doesn't work. And I see students do this all the time when A is not 1. You know, maybe there's an example that you have 3x squared plus 6x plus 10. I'm just thinking about an example here. And we can't do too much here, and we would have to do some factoring, but A is not 1. So this is where we would skip a step. This is where we would not skip a step. We would apply this little bonus here because that is one way to do this. And it depends on how you want to look at that. So I'm hoping that you find this video very enlightening because it's very important that you factor in classes, and you can't forget factoring because factoring is going to be sticking with you for all your math career. So hope that worked, and I will see you on the next